Okay guys, now we have the last section in this chapter, which is potential energy curves. It is simple idea. Assume that we have total mechanical energy, for example, 100 joules. This is the total mechanical energy. If we have as a part of this mechanical energy is 30 joules as a kinetic energy, then the rest of this mechanical energy is 70, which is 100 minus 30. And also, if this kinetic energy or potential energy change its value, the other one will change to have a constant mechanical energy. So if we have kinetic energy now, it's 52, then the potential energy will be 48. So all the time for conservative mechanical energy, we have constant value for this mechanical energy, and it is always equal to the kinetic energy plus the potential energy. Now let us take this idea using graphs. What if we have XY plane in mathematics, but in physics we need it in different way. We need to see that the X axis is with X or distance, which is displacement or length in meters, and the Y axis is the potential energy in joules. We know that the potential energy, the gravitational one, is mgh. We can put x in the place of h, because x it's a length or height. H in general, it's height, it's a length. Also, the potential energy due to spring, and this is for gravitational, is equal to half kx squared. So from this formula or this formula, U, which is the differential, which is the potential energy, is a function of length. It is clear that it is a function of length. So XY plane is X length or with potential energy plane. What if we have this arbitrary curve for our system, and the potential energy is divided on the Y plane and the vertical plane axis as 10, 20, 25, as we see here, and the length axis is divided by tens in meters. Okay, we need to be sure that the mechanical energy, the change in mechanical energy is zero, because we have conservative forces. The mechanical energy will be the same, which is equal to the potential energy plus the kinetic energy. Now from this curve, what we can find, be careful to what I need to do. The maximum in our curve from this point to this point, the maximum energy is at the maximum potential. Here, look. This is E potential or U max, the maximum potential energy. Let us assume that at this potential we don't have any velocity for our body. This system for a body with a potential energy and kinetic energy. If the potential, if V is equal to 0 at this point, then the mechanical energy will equal to the potential energy plus the kinetic energy, but the kinetic energy is equal to 0 because the velocity is 0. Okay, so how much the mechanical energy at point 0? Mechanical energy at point 0 is equal to the potential energy at point 0, which is 50 joules. How much the kinetic energy? It is 0. So the mechanical energy will remain constant all over the curve. Okay, so this is the mechanical energy. We can call it E0. Okay, which is equal to the potential energy at maximum value. Maybe the maximum value be not at the beginning, maybe it is at a different point, but the potential value, the maximum potential energy, is the Emax at that point if the velocity is 0. If I ask you to find the kinetic energy at x equal 40, at x equal 40 you can find the potential energy and you can reflect it from x horizontal axis to vertical axis. So the potential energy here at x equal 40, U is approximately 22 joules. How much the potential energy for this value of distance, the kinetic energy, how much the kinetic energy? K is equal to the difference between the total mechanical energy minus 22, which is 50 minus 22, which will be 28 joules. From that I can find the velocity. It is easy. What is the kinetic energy at point x equal 100? I need to find the potential energy at this point. The potential energy, it will reflect 30. U is equal to 30 joules. Then the kinetic energy will be the rest, which is 20 joules as kinetic energy. Also, if I ask you how much the maximum kinetic energy, how much the maximum velocity, the maximum kinetic energy means the minimum potential energy. Where's the minimum potential energy? It is even this point or this point. We can easily see that it is this point at x equal approximately 28 meters. At this point, the potential energy, we can see it. It is approximately U is equal to 15 joules. So U minimum is equal to 15 joules. How many kinetic energy maximum? It is 50 minus 15, which is 35 joules. From this point I can find V maximum, because V squared is equal to 2 multiplied by from that formula, which is under the 2 multiplied by the mechanical energy divided by m. I think if you remember that, but here it is not. It will equal to 2 divided by m multiplied by the change between the potential, the mechanical energy minus the potential energy. The change, it is 35. So V squared is equal to 2 multiplied by 35, which is the kinetic energy, divided by m. If I need to give you m is equal to 2 kilograms, then you can find the velocity. V not squared, because we use the root here. Okay, so using this graph will give us the kinetic energy, the velocity, the minimum value of potential energy, the maximum value, and the minimum value also on kinetic energy. It is 0 here. Is that clear? You can use any graph and find the potential energy by using this technique, and the kinetic energy. This is the end point of this chapter, and good luck.